Planning basics, introduction overview, deep learning in one slide. What is it? Extra useful patterns from data. How neural network plus optimization. How practical Python plus TensorFlow difference. Hard part, good questions plus good data. Why now? Data, hardware, community tools, investment. Where do we stand? Most big questions of intelligence have not been answered nor properly formulated. Existing progress. Face recognition, image classification, speech recognition, text to speech generation, handwriting transcription, machine translation, medical diagnosis, cost, drivable area, landscaping, digital assistance, ads, search, social recommendations, game playing with the deep RL. History of deep learning ideas and milestones. We are here. Perspective. Universe created 13.8 billion years ago. Earth created 4.54 billion years ago. Modern humans 3,000 300,000 years ago. Civilization 12,000 years ago. Written record 5,000 years ago. In 1943, neural networks. 1957, perceptron. 1974 to 76, propagation. RBM, RNN. 1989 to 98, CNN, MNIST, LSTM, bidirectional RNN. 2006, deep learning, DeepN. 2009, ImageNet. 2012, AlexNet, Dropout. 2004, 14, CANs. 2014, Deep Space. 2016, AlphaGo. 2017, AlphaZero Capsule Network. 2018, PET. Dates are formed perspective and not as definitive historical record of invention or credit. History of deep learning tools. Mark 1 Perceptron 1960, Torch 2002, CUDA 2007, Theano 2008, Caffe 2014, Dist Leaf 2011, TensorFlow point 1 2015, PyTorch point 1 2017, TensorFlow 1.0 to 2017. After 2017, in PyTorch 1.0 2017, TensorFlow 2 2019, truncated for clarity over completeness. First step, start simple. Everything should be made as simple as possible, but not similar. Input image, neural network file. Input image, TensorFlow model, output file. It is 87% confidence. 1, 2, 3, 4, 5, 6. Import TensorFlow as TF. From TensorFlow, import take as get data 71, get data, train image, train labels, test images, test labels, keras dot datasets dot mnist dot load underscore data. Setup model. This import TensorFlow and keras TF keras not vanilla keras. Second one, get data. Third one, setup model 1. Third one. Fourth one, train model. Fifth one, evaluated. Sixth one, make predictions. So here in setup model equal to keras dot sequential, keras layer, flatron, input image, input shape and 28, 28, then 28 dot activation TF dot NNRELU. Keras layers 10 of 10, activation TF dot NN at softmax model dot compile of optimizer TF train optimizer loss path categorical cross probing metrics, accuracy, train model, model FIT, train images, train labels, approaches, evaluate test last test accelerator model, evaluate test images, test labels, read test accuracy. Sixth, make uh, predictions model, predictive test image. TensorFlow in one slide. What is it? Deep learning library and more. Facts, open source, Python, Google, community. Facts, open source, Python, Google, community, 117,000 plus. GitHub, representation matters. Cartesian coordinates, polar coordinates. Draw a line to separate the green triangle and the blue circles. Deep learning is representation learning, aka feature learning. Task: draw a line to separate the blue curve and the red curve. Matters: heliocentrism, geocentrism. Some centered model formed by Copernicus in 16th century. Each is centered model. History is science is a history of comparison process. Why deep learning? Scalable machine learning, input, feature extraction, classification, output. In deep learning, machine learning like this, in deep learning, input called feature extraction, classification, then output. Here, feature extraction. After that, it will be classified. So, amount of data, performance, most learning algorithms, deep learning. So, why deep learning under scalar machine learning? Here, in the machine learning, feature extraction, this is the same input called feature extraction, here no classification. That's why in amount of data x-axis, y-axis performance, here deep learning performance is very good than most learning algorithms. Gartner hype cycle, x-axis time, y-axis feasibility, deep learning, peak inflated expectations, self-driving cars, platinum productivity, slope enlightenment, touch of disillusionment, technology trigger. Why not deep learning? Real world applications. These all are real world applications. Why not deep learning? Unintended consequences. Human. AI. Deep oral agent. Player gets reward based on finishing time, finishing position, picking up turbos. Why not deep learning? Unintended consequences. Human. AI deep oral agent. Player gets reward based on finishing time, finishing position, picking up tables. The challenge of deep learning: ask the right questions and know what the answer means. Image classification not equal to scene understanding. Select, collect and organize the right data to train on photos, synthetic, real world performance. Visual understanding is harder. Examples of what we can't do well: mirrors, sparse information, 3D structure, physics. Wow, what is on people's minds? What happens next? Human. In deep learning, our intuition about what hard is flawed in complicated ways. Visual perception, yes, data. Bipedal movement, this much yes, data. Abstract thought, 100,000 years of data. Prediction dark plus distortion, prediction, postage. Encoded in the largely highly evolved sensory and motor portions of the human brain is a billion years of experience about the nature of the world and how the to survive in it abstract thought though is a new trick perhaps less than 100,000 years old we have not yet mastered it. It is not all that intrinsically difficult, it just seems to so when we do it. Measuring progress in STEAM is seventh. Art, cinematography, management, social interaction, investment, translation, driving, go, speech recognition, vision, rate memorization, arithmetic, chess, geometry, theorem verification, theorem proving, in test, programming, book writing, AI design, science, cinematography, maths, tech bots, pricing, see solution of Hans Marcos, landscape of landscape competency, estimation, apartment cost, special purpose intelligence. Yes, input bedrooms 3, square feet 2000, neighborhood mapped to an ID number, temperature value 1, temperature value 2, 3, 4. Then we got final price estimate. Poked pixels 05, policy network raw pixels hidden layer, probability of moving UP 80 plus 80 image difference image, two actions up or down, 200,000 phone games is a step towards general purpose artificial intelligence. Data augmentation, crop, flip, scale, rotate, translation, noise. Data augmentation, crop, flip, scale, rotate, translation, noise. This much. How neural networks learn back propagation, followed by a pass. Input data given to neural network output given to prediction. And followed by a pass. Input data given to neural network given to prediction. Here multi-class versus multi-level. Multi-level. Sample 3 C equal to 3. Here label T 001 100 010 samples label T 101 010 11 111. So here biological and artificial neural network, human brain, thalamocortical system, 3 million neurons, 476 million synapses, 4 brain, full brain, 1000 billion neurons, 100 billion neurons, full brain, 1000 trillion synapses. Artificial neural network, reset net 152, 6 million synapses. Human brains have 10 lakh times approximately synapses than artificial neural networks. Neuron forward base for 1.4, 0.6, 0.7, some bias